As for Chapter 7, domain conversion. The workflow of converting data between domains within Bitwell is split into simple processes. Make the velocity model, defines how the velocity varies in space or as a 3D environment. Depth conversion uses the velocity model to convert data from between domains. The most important step to convert between domains, you need to have the velocity model. When you build the velocity model, you can convert mostly everything in your project, and from time domain to depth domain. The velocity model. Velocity model can be defined in 3 ways. Using establishing time-depth relationship from wells to distribute velocities trend throughout the area. Loading sig-y velocity volume that is used to extract velocity from. As a first step to establish the time-depth relationship, you need to have many wells around your areas which is not close to each other. To represent, each well represent a point through the area. We'll take the average between these points. You need to have a lot of wells, a lot of check shots, so it will cover the area perfectly. Without, you can't manage to do the time-depth relationship. Loading the sig-y velocity model. Here's, you can load a ready volume of velocity model. You can load a seismic cube, but not in the seismic traces. It's the whole seismic representing the velocity. So it's simple way, but we don't have this volume. So as third, you can use based on stacking velocity points. You can use stacking velocity points. This point is much close to the first point. Use points stacking above each other, representing the whole area. You can take the average between them, and then you can manage to create the velocity model. The velocity model requires 4 sets of inputs. A zone description, for example, a set of surfaces. You set a surface as two-way time. That will take it as a zone description. Define where's your zone that need to be to make the velocity points from. A definition of the velocity model for each zone. For example, V is equal to V initial. V is representing the velocity. This you have to give a value for the V so it can be calculated. Input parameters for the velocity model, for example, a surface. You can use a surface, but this surface it's used in depth, which is not be created yet. So, this step is important when you later on you need to regenerate your velocity model, as you need to see if there is an error or something. So you use the surface in depth domain, not in time domain. Correction data, if required. Correction data, for example, you can use your check shots, which has been used in our velocity model. The velocity had to be taken one value averaged through each surface. We couldn't use any of the 3 steps of creating the velocity model: the time depth relationship and the velocity stacking, or the volume sig-y cube. Because that we had to give one average value of the velocity through each surface. This is the way that average value has been extracted. As can you see here, the well name, we use 2 wells as usual because they are the only wells we used as scientific seismogram. 170 and 292. We took the average velocity representing for each well from the check shots. We took the from 170 a point that in the surface on the member 5AB and the member 292. We had to take, so when you put the 2 wells beside each other, you will have a velocity, average velocity point, and for a well here and a well here. So you can't just take a value. If you, I tried the 3 ways. I took a value of the 170, and as a second, I took a value of 292. Then I took the average between them. After comparing the 3 results, I found taking the average between 2 wells is much better and much realistic and showing the accurate location of our cube. If you didn't, if the location of the cube wasn't represented good, that will cause problems. Maybe the water architect will will cross over above member 3, which will cause a problem because it's lower. And if you take the value is lower than expected, the water oil contact will go lower and the volume will increase of the volume and won't represent an actual study. As can you see here, the datum and horizons in time after being converted, horizons in depth. The scale of the horizon from time to depth, it will go larger because from time to depth, it's the scale of the time would be lower and the scale of the depth would be larger. Here is showing the member 5 EB in depth. As can you see, the scale of the surface has been increased. And better you can control the scale of the Z values in showing your model. That will help you in representing or showing your results in a better one. Here, the member 3 in depth domain. And here is the member 2 in depth domain. 3D grid depth conversion. Now for the important step, we need to convert our 3D grids or 3D model from time domain to depth domain so we can calculate the volume and do the property modeling and everything. Here, as you can see, the 3D grid has been converted from time to depth. The scale has been going larger as I discussed. And here's our volume in 3D. Hello again.